Hi there, and welcome to my channel. In this question, we are given function f of x, which is the integral from 0 to x of 1 over the square root of t cubed plus 2 dt. And then we are given 5 statements, and we need to find which one of those is false. So there are 4 true statements and 1 false statement. And let's take them one at a time. So first one is f of x equals the integral from 0 to x. Let's just rewrite what we are given here. Square root of t cubed plus 2 dt. And so f of 0 is equal to the integral from 0 to 0 of the 1 over the square root of t cubed plus 2 dt, which is indeed 0 because the upper and lower limit of integration is the same. So the first statement is true, so that's not the answer. Second statement is f is continuous for all x greater than 0. And so let's look at the derivative of f. And if we show that the derivative exists, then it means that the function is differentiable and thus it is continuous. So the derivative of the function is equal to v over dx, or the integral from 0 to x, 1 over t cubed plus 2 square root of that dt. And so the derivative in this case, we just plug in x in the function under the integral. So this is equal to 1 over square root of x cubed plus 2. And we see that this is defined for all positive x's. The derivative, the denominator is never 0. So this is always positive and defined. So the function is differentiable for all x greater than 0 and thus continuous. So b is true, so cannot be an answer. The fourth is that the f of 1 is positive. So f of 1 is integral from 0 to 1 of 1 over t cubed plus 2 dt. And let's graph this function here. Let's take a look at the function f of x. So this integral from 0 to 1. And then we see that t is between 1 and 0. So cubing all those sides, t cubed is between 1 and 0 as well. T cubed plus 2 is between 3 and 2. Taking the square root gives us, this is between square root of 2 less than the square root of t cubed plus 2 less than square root of 3. And then when we divide 1 by this number, we need to change the inequality sign. So this becomes 1 over square root of 2 is greater than 1 over the square root of t cubed plus 2 greater than 1 over square root of 3. So we see that this function is positive on the interval from 0 to 1. So somewhere it starts at 1 over square root of 2. So it's here is 1 over square root of 2. Here is 1 over square root of 3. And then it somehow smoothly connects these 2 points. So f of 1 is greater than 0, and it's the area under this curve, so it's positive. So the third statement that we see here is also true. So f of 1 is greater than 0. Now let's take a look at the first statement, statement D. F prime of 1 is equal to the square root 1 over the square root of 3. And we found the derivative right here in this part. So let's plug in x equals 1. We see that the f prime of 1 equals 1 over the square root of 1 cubed plus 2, which is indeed equal 1 plus the square root of 3. So this is also a true statement, so this is not the answer. So we already know that the answer is E, if we didn't make any mistakes. But let's just confirm that f of -1 is greater than 0 is false statement. So f of -1 is less than 0. And so let's write f of -1. This is equal to the integral from 0 to -1 of 1 over square root of t cubed plus 2 dt, which is equal to changing the order of integration, and this is equal to negative integral from -1 to 0, 1 over the square root of t cubed plus 2 dt. And we can show in a similar fashion, and let's do that, that the expression of 1 over the square root of t cubed plus 2 is greater than 0 for t, which belongs to the interval from -1 to 0. And let's just do that. So if t is between 0 and -1, then it means that t cubed is between 0 and also -1, which means that t cubed plus 2 is between 2 and 1. And then taking the square root gives us it's between 1 less than square root of t cubed plus 2 and square root of 2. And then flipping 1 over still gives us the relationship that 1 is greater than 1 over the square root of t cubed plus 2 and greater than 1 over square root of 2. So we can see that this is positive. And because the expression under the integral, this expression is positive, this is greater than 0, the integral is positive, and multiplying by -1 up front here gives us that this is negative. So f of -1 is actually negative. So the answer, as we already confirmed by eliminating all the other choices, is indeed E. That's a false statement. Thank you for watching. If you liked this video, please don't forget to click the like button. Also, write me your comments in the space below and subscribe to my channel, where you can find more solutions to the Calculus AB and Calculus BC problems. And I will see you in the next video.